All right, today for Algebra 1, we're doing 2.4, solving one-step equations. Okay, so the first thing to notice kind of today is that you have a worksheet. WS is worksheet for homework. On this worksheet, you must show every step exactly as I'm showing you today. Okay, I know that these problems are very easy. You do not need to show your step because you can do them in your head, but this is the time to learn to show your work, to balance an equation. Okay, we're going to solve a one-step equation we're called balancing. Okay, you must learn to show your steps and show the work now, because tomorrow we're going to go to two-step, and then next week, if not this week, we're going to go to more complex ones. So you have to start showing your work, okay? All right, so the objectives today. We're going to determine whether an equation is true or false, because yeah, sometimes equations can be false. We're going to identify and apply the properties of equality when solving one-step equations. So which properties we're using. And we're going to translate word sentences into algebraic equations and then solve. So first up, an equation. We talked on this a little bit last week. It's a mathematical sentence stating that two expressions are equal. Okay, that's the big thing. An equation has an equal sign, an expression does not. There's no equal sign. Okay, so in an equation, if two quantities are equal, we're right here, it does not matter which side of the equal sign they are placed on. Okay, so that kind of goes over here. This is that symmetric property of equality. We have if A equals B, then B equals A. It doesn't matter what side they're placed on. Okay, it's an equality. Okay, so going back down here, equations can be true or false, which is kind of crazy. But, because you probably haven't seen those yet. To be true, both sides must be equal. So we're going to look at two examples here. This side, okay, when we're talking about the sides of an equation, we're splitting it at the equal sign. So we're looking at 3 squared minus 5 times 7. It says it's equal to negative 2 times 13. We solve both sides and see if they're equal. So 3 squared is 9, 5 times 7 is 35. 9 minus 35 is negative 26. Negative 2 times 13 is negative 26. We just bring that down again and say negative 26. So now we could say, hey, negative 26 does equal negative 26. So this is true because both sides are equal. In this other equation, okay, again, you split an equation at the equal sign. So we have 4 times 5 equals 3 plus 2 times 4. Well, 4 times 5 is 20. Here we did 3 plus 2 times 4. 2 times 4 is 8. So now we have 3 plus 8 is 11. So 20 equals 11. This is not true. This is false because the sides are not equal. Okay, so we can have true, this is how we can have true and false equations. All right, so let's move on down there. All right, so then we have next an inverse operation. Okay, the operation that will reverse or undo a given operation. Okay, so our inverse operations, if we look over here, okay, about these, if we have addition, the inverse is subtraction. A subtraction undoes addition. And vice versa, if we have subtraction, the inverse is addition. They undo each other. Multiplication's inverse is division, and division's inverse is multiplication. So here's the thing, when we use these, we must do the same operation on both sides of the equal sign. That is what keeps it balanced. It's like a teeter-totter. Okay, if you think of a teeter-totter, all right, if you put a person on this side, what happens to the teeter-totter? Well, it goes down like this, right? Okay, in order to keep the teeter-totter balanced, we have to do the same thing on both sides of the teeter-totter. If we put a person on the left, we have to put a person on the right. okay, to keep them balanced. So whatever you do on the left, you have to do on the right, or one side or the other. Okay, so solving equations. First step is determine the operation that's performed on the variable in the equation. Okay, so what's actually being done to the variable in the equation. Then we're going to perform the inverse. Okay, we didn't actually perform that. We determine, in step one, we determine the operation and then we perform the inverse. Again, on both sides of the equation. Then we simplify both sides and then we can check our answer. All right, so example one, we're going to get started. I'm going to draw a line here to help us think that this is like our teeter-totter. Okay, the sides look a little different there, but that's okay. We have x minus 12 equals 15. So it said determine what's being done. Well, subtraction is what's being performed. We're subtracting 12. We need to do the inverse. So we're going to add 12 to both sides. So when we do that, x minus 12 plus 12, well, the minus 12 plus 12 cancels out. So we're just left with x. And now 15 plus 12 is 27. This is the work that I expect you to show on your worksheet tonight. Okay, this is exactly what I'm talking about, what I'm showing you now. So copy this down exactly like I'm doing it. All right, so for our next one, B, 3x equals 18. I'm going to draw my teeter-totter. I'm looking at what's being performed. What's happening to the 3 and the x? Well, that's multiplication. So we're going to divide by 3 because it's being multiplied by 3. Okay, well, x times 3 divided by 3, those cancel and leave us with x. X divided by, or 18 divided by 3 is 6. Okay, again, showing this work, that's exactly what I'm talking about. On C, y plus 7 equals 24. I'm going to draw my teeter-totter. Okay, notice my line down is always going at my equal sign. The first time I kind of cut through it and touched it, but it's always there at my equal sign. That's where the half is. Okay, what's being performed or done to the y? Well, we're adding 7 to it, so we're going to do the inverse. What is the inverse? Good, subtract 7 on both sides. Okay, plus 7 and minus 7 are going to cancel, which gives us just y here. That's left. Our equal sign, 24 minus 7 is, good, 17. Okay, I'm going to move up, clear my board and move up a little bit, because now we're going to get into some with that have some fractions in them. Okay, so x plus 2/3 equals negative 7/12. All right, what operation is being performed? Addition. So we're going to do the inverse, which is, excellent, subtraction. So minus 2/3 on both sides. Plus 2/3 and minus 2/3 cancel, leaving us with just the x to bring down. Negative 7/12 minus 2/3. We're going to have to do some work there to get those common denominators. So I would multiply by 4. So this is going to be minus 8/12. So what's negative 7/12 minus 8/12? Or we can add the opposite, which would make this plus a negative 8. Negative 7 plus negative 8 would be negative 15/12. And we should simplify this, right? Because 15 and 12 have common denominators. So it'd stay negative. Divide both of them by 3. So we get negative 5/4. Okay, negative 5/4. Again, I don't care that it's improper at all, as long as it's simplified. But if you want to make it negative 1 1/4, that is okay. All right, E. I'm going to put my teeter-totter on here. Now this one's a little harder maybe for you to tell what is happening, what operation is happening here. But fractions are what operation? Good. Fractions are division. So we're taking x and dividing by 7. So we need to multiply by 7. So you might see me use the dot or parentheses for 7, but I won't use the x usually. All right, so dividing by 7 and multiplying by 7 cancel, leaving us with just x. Negative 13 divided by 7. Okay, so a negative times a positive is a negative. 13 times 7 is 91. One more. Teeter-totter. Okay, at the equal sign are my two sides. What's the operation being done here? 3x. Good, it's multiplication, so we're going to divide. So I'm going to divide by 3 on both sides. Times 3 and divided by 3 cancels, leaves us with x. On the left, 99 divided by 3 is perfect, 33. Okay, so showing every single step. Again, I believe you could do all of these in your head, except for maybe D. Okay, you might take some paper and pen to do D, but I need to see every step. What are you doing to show me the inverse, and what is your solution? Okay. Okay. Now, example 5, we're going to justify each step in the solution. We're going to justify each step in the solution. Now, we're going to use these properties down here, the properties of equality. I should have moved this to the up there, I guess, but I wasn't thinking. So we're going to figure out which property of equality really are we using in each step in example 5. Okay, so you have to keep that in mind. All right, so let's actually do the solution of this. We're going to have to solve it first. All right, so we have x minus 2 equals 5/3. Again, we need to figure out what's happening here. So if I've got my teeter-totter, that's a little high, I suppose. So let me make it a little lower. There we go. So there's my little teeter-totter. Okay, and what operation is happening? Subtraction. Good. So we're going to do the inverse, which is excellent, addition. So we're going to add 2/9 to both sides of our equation. Minus 2/9 and plus 2/9 cancel. So we're left with x equals, we have 5/3 plus 2/9. We need to do some common denominators. So I'm going to multiply by 3. So that would give me 15/9 plus 2/9, which is going to give me 17/9. Okay, but here's the thing. We need to justify each step. Okay, that's what it says, justify each step. So this step right here, all right, which property of equality did we use that's down there at the bottom? Which property of equality? Good, it's the addition property. So I'm going to have the addition property, prop of equality. So the addition property of equality there because we had subtraction and we added. Our next step, okay, it's like how did we get from here to here? Well, in this case, it's not actually a property. We just did addition. The step there is addition. Okay, so just using some of those to be like, all right, well, how did I get from here, right, to here? We use the addition property of equality. Then how did I get from here to my actual final answer? We did addition. We did the addition. All right, example 6 says the difference of a number and 10 is 37. Find the number. All right, so we have to translate this into an equation, and then we're going to solve it. Okay, so let's look here. We have the difference. Difference means what? Good, subtraction. Of a number, okay, a number could be, let's use n, good, and is always helpful, and 10. Okay, 10 is the number 10. Is huge, is means equals, and 37. Okay, so we know we're doing subtraction between a number and 10, and that equals 37. So this subtraction goes right in here, right? The difference of a number and 10 goes right inside there. So we have n minus 10 equals 37. All right, I'm going to put up my teeter-totter and split it right at the equal sign so I remember. What's happening in my problem? N minus 10. I'm subtracting, so I need to do, good, addition. So I'm going to add 10 to both sides. On the left, where I subtracted 10 and added 10, those cancel. Those cancel and leave me with n. On the right, where I have 37 plus 10, that equals 47. So your number is 47. Again, you probably didn't need to write an equation. You probably didn't need to balance and solve the equation to show me how to do it. You probably could have done it in your head. That is not acceptable. You must show me the work. All right. Then we're going to talk about two different types of equations. And we have conditional equations and literal equations. A conditional equation is an equation whose truth, so the truth, depends on the value of the variable. All right, so x plus 4 equals 7. It is true if x equals 3. However, it's going to be false if x equals 2. Okay, so those are conditional. Then we have literal equations. These are equations that contain more than one variable. They're called literal. So these are some examples. Y equals mx, excuse me, y equals mx plus b. There's 4 variables here. A equals pi times the radius squared. There's 2 variables, a and the radius. Pi is a constant. I equals PRT, 4 variables. D equals RT, 3 variables. Any of those are called literal equations. Now the cool thing about these is that you can solve for any letter that you want. So in example 7, it says solve this formula, or this literal equation, for A. Okay, so we're solving for A. We have F equals M times A. We don't want that. We want A equals. That's what this means. Okay, so we're going to take F equals M times A. And we're going to draw, I'm going to draw my teeter-totter. Remember, I want to solve it for A. I want to know what A equals. So we have to think, what operation is happening here? M-A, M-A. What operation is happening between these two? Good, it is multiplication. It is M times A. We need to do the inverse of multiplication, which is, excellent, division. So we're going to divide by M. So we have A left over. We're going to divide by M on both sides. Okay, so if we have M times A divided by M, the M's cancel. And so we're going to have A left over. A equals F divided by M. Or you might write F divided by M. Okay, you could write it either way. I will typically write it as a fraction. I do not like using the division sign. Fractions are division. It's a good thing for you to remember. So either of those I will take, however. So you can have F divided by M equals A, or F over M, because that's division, equals A. But you did exactly what it said. It said solve for A, and now you know what A equals. You could rewrite this to say A equals F divided by M, if that makes you feel better. That goes back to where we started, right? That property where we started that said it could be equal on either side. It does not matter. Okay, when we started that symmetric property of equality. All right, so then you have your worksheet. Remember, you must show me all the steps. Like it should be 2 steps for every single problem in your homework. 2 steps for every single problem, and balancing it, doing it on both sides. Okay, have a great day. I will see you guys tomorrow.